We will now look at question 7. Figure 7.1 shows 0.024 grams of air in a cylinder at room temperature, and the piston is free to move. And as I increase temperature, the piston moves outwards and stops at the position shown in figure 7.2. Calculate the density of air in figure 7.2. So if we recall from the keyword density, the formula for density of air is equal to the mass of the air divided by the volume that the air takes up. So from figure 7.2, we can see that the volume taken up by the air is 30 cm cubed. And the question also tells us that I have 0.024 grams of air. So therefore, the density of air, since the mass of the air remains constant in this cylinder, is simply equal to 0.024 divided by 30. Okay, and therefore my answer would be equal to 0.00080 grams per cm cube. This will be the answer for part A. Part B, the air in cylinder in figure 7.1 and figure 7.2 creates pressure. Explain how the molecules in the cylinder creates pressure. So if we recall the definition of pressure, pressure is simply force per unit area. So how they create pressure is simply because the air molecules exert a force onto the cylinder walls. To exert pressure. So this is simply how we have gas pressure inside a cylinder. Part C, the readings of the volume of trapped air in figure 7.1 and figure 7.2 are different. State the physical property of a gas that causes this reading to be different. So gas has different readings, and the physical property that causes this is simply because gas is compressible, or you can also say that the volume of gas is not fixed. And part 2, explain using the KMM why the physical property stated in C part I allows the readings of the volume of trapped air to be different. So using the kinetic model of matter, gas is compressible because gas molecules are spaced far apart. And they also have weak intermolecular forces of attraction. So these are two important points. Spaced far apart and weak intermolecular forces of attraction will be the important points to state to score this mark. And this will be all for question 7.